Hello students, I welcome you all in the discussion of the quick solutions of All India AIATS Test Series Medical 2019. And we are just going to discuss test number 8, code A and B, and we are going to deal with the chemistry section of this paper. Let's begin with the question number 46. Number of nucleons present in 0.2 mole of D2O. What's this D2O? This is heavy water we're talking about. And in case of this heavy water, how many nucleons are present? First thing, and the number of moles are also given. So we should know that whenever we talk about the one molecule of D2O, the heavy water, that contains how many nucleons? In this case, deuterium is there, that's the heavy hydrogen. One proton is there, one neutron is there. It means two nucleons are present in this deuterium, and there are two atoms of deuterium. So simply there would be 2 into 2 nucleons in case of D2. And if we talk about oxygen, in case of oxygen, total number of nucleons are 16. Why 16? Because there are 2 proton and 2 neutron. So it would becomes 20 nucleons, which are present in case of one molecule of D2O. But we have 0.2 mole. So if we talk about 0.2 mole of D2O, what does it mean? It means that there are 0.2 into any number of the molecules. Now on the basis of this, how many nucleons are there? We know that one molecule contains 20 nucleons. That's why 0.2 into 20 Na, and that's equal to definitely 4 Na molecules. Where these are present? These 4 Na molecules are present here in option 4. That's why what would be the correct answer? That's definitely option 4. After that, question number 47. Which of the following pairs of orbitals will have electron density along the axis? To identify this, what you have to do, you have to just see the structure of these orbitals. We have first option in which px and dxy orbitals are given. Here in the second option py and dyz. In third option pz and dzx. While in fourth option there is px and dx square minus y square. In this case, you just have to look at the structure of the p orbitals as well as d orbitals. You will identify that this px orbital is axial. It means electron density is there along the axis. While if we talk about dxy, there is the electron density between the axis. That's why this is dxy, between x and y axis. So in this case, you cannot say that density is along the axis. So we can leave this option further. Py, definitely density is there along the y-axis, but dyz, in this case, electron density is not there along the axis. That's why it's wrong. Further, pz and dzx. If we talk about pz, density is along, electron density we are talking about, electron density is along z-axis, while in case of dzx, again, electron density is not along the axis. That's why it's ruled out further. Px, definitely density is along the x-axis. For the dx square minus y square, yes, in this case also, electron density is there along the axis. And on that basis, it's the correct one. So I'm just choosing option 4 as the correct option. After that, question number 48. Maximum number of electrons present in an atom having n is equal to 3 and L is equal to 2 value. It means the two things that we have, quantum numbers, one is n is 3 and L is azimuthal quantum number, that's 2. We know that for the shell, if n value is 3, it means we are talking about third shell. Further, L value is also given, that's 2. On the basis of this, it is for d subshell. So this is 3d orbital. We know that in case of d subshell, there are 5 d orbitals, and in one d orbital, maximum 2 electrons can accommodate. So if we talk about the maximum number of electrons, those are present in the given orbital, those would be 10. Why 10? Because 5 orbitals are there and maximum 2 electrons can accommodate in one orbital. That's why 10 electrons would be there. and on that basis option 2 is the correct answer. And after this, there's a turn for question number 49. An element has its electronic configuration 1s2, 2s2, 2p6, 3s2, 3p6, 4s2 and 3d8. In which group of the periodic table this element can be present? So in this question we have to look at the last electronic configuration, that is 4s2, 3d8. It means the valence electrons are present here in 4s2 and then 3d8. In this case, this is the configuration for the element nickel. Basically, the atomic number 28 is represented here, and this is present in 4th period and 10th group. Because the number of period you can identify by considering the n value of the valence shell. You can clearly see here it is 4, n is 4 for this. Now further, if we talk about the number of group, there's a small trick. What's that trick? You just add the number of electrons present in d orbital and the number of electrons present in s orbital of the last shell. So there are total 10 electrons, and on that basis the group associated with this configuration is 10th group. And yes, on the basis of this, and choose correct option, that is option 3. After this, question number 50. The correct shape of ICl2 positive and hybridization of I in ICl2 positive respectively are. In this case, we have the species, that is ICl2 positive. This is the species, and we need to just find out the hybridization of I in this and the correct shape of this species. Now, if we talk about hybridization, it is sp3 hybridized. And the shape would be bent due to the presence of 2 lone pairs here. This is the species we have, and now on the basis of this, it's bent because 2 lone pairs are present on I. That's why it is bent in shape. And yes, on the basis of this, option 3 is the correct option that I will choose here. After that, question number 51.